classes is none, so we'll step over that. And now we're here. X-shape, well, we know that there is shape there because we have 9. So n will be 9. So we'll step over that. And now here, let's unwrap it in our collab. But actually, before we do that, we forgot to do one thing. And you can see that in addition to the concatenation, we had this here as well. So we actually did just one part of it, but we forgot to do this part here. So let me show you. So conf, well, we know conf is this. If we do conf.view -1, essentially what we're doing is for this 9x1, reduce one dimension. So let me show you. So we have a 9x1 tensor in conf, and we want to reduce one dimension. So this 9x1 will become 9. And then what we're doing here is, out of all these predictions, we want to check one more time which ones are above 0.5. So in this case, they're all above 0.5. So the return of X will be essentially all of them. But if one or more of them would have been false, then we wouldn't have output those. And you might be asking, why do we need to do that? We already did that step. Well, we kind of did that step, but not exactly. So here we calculated which ones are above the confidence threshold. But remember that later, we multiply that confidence score by the individual confidence for each class. And yes, we check for each prediction to make sure that this value was above 0.5. But given that now we've multiplied this value by a value that is less than 1, we're going to obtain for each class a smaller value. So in our case, we multiply this value by 0.89 and we obtain 0.86. So in this last check, we want to make sure that the maximum value for each class, we want to make sure that that is also above 0.5. And this will always be lower than this value because we're multiplying the classes by a value that is smaller than 1. So it's just final check to make sure that all our combined scores also meet the 0.5 criteria. So you can see just a double check. We first check that the objectiveness score is above 0.5. And then when we perform this multiplication and we get the maximum of the class, we also make sure that that class is above 0.5. Now, that value of X, you can see that our maximum is right here in index 4. So we want to call the arcsort method to actually sort it from highest score to lowest score. And this is exactly what this method does, where it's going to return the indexes sorted in our case, descending order. So you can see that by default, descending is set to false. So we're calling descending set to true. So we have the highest value at the top and the lowest value at the bottom. So when we run this, you can see that 4, which is the highest, now we have that index, and then the second highest is index 1, and then 7, and so forth. And then with that, given that we don't want to feed more than 30,000 boxes to the non-max suppression algorithm, we're basically, if we had more than that, of course, in our case, we only have 9, so that's no problem. But if we had more than 30,000, then we would clip it at 30,000 and not more. And this makes sure that in the case where your confidence threshold is very low, that things don't blow up, even though in the majority of use cases it's way, way less. As in our case, we only have 9. So we obtain the same result. And just one more time, if we print X, again, nothing new here. And now if we do the whole thing in one line, we're calling you can see here, the arcsort. And then here we're going to obtain these indexes. And what this is going to do is X is going to be sorted and reorganized with this index priority in mind. So you can see that now index 4 now is first, as well as index 1 now is second, and so forth. And we can do the same in our VS Code. So let's just run this line. And just double check, you can see that we obtain the same results, 91.73, 91.73.